this first project, we have learned how to model a simple physical problem, the water level changing in a tank due to an inflow and an outflow. The problem is described by a differential equation that we had to integrate to obtain the history of the water level in time. We learned how to compute an approximated solution advancing in time with steps of length delta t using a method that is called the explicit Euler's method. And then we have learned how to translate this algorithm into computer code in Python and in MATLAB. First of all, we have seen how we can define the simple inputs for our simulation and store them in memory as floating point numbers. And then we have learned how to use containers to store many values in a single structure. Just remember that in Python, to access the elements of a list, we use square brackets and the index starts from 0, whereas in MATLAB, to access an element of an array, we use round brackets and the index starts from 1. We have learned how to create a function that takes inputs and produces an output, and we have used it to define the outflow rate. In Python, functions are written using the keywords def and return, whereas in MATLAB, the simplest way to write a function is with the @ syntax. Finally, to apply the Euler's method many times automatically, we have learned how to write a loop, in particular a for loop. And in both languages, we have used the counter n to keep track of the iterations. Thanks to the plot functions, we have produced a graph of our solution over time for an easier interpretation of the results. What we can do now is perform what is called a parametric study of the problem, that is, see what happens to the solution if we change some of the input parameters. Here, for instance, we can see what happens if we increase the outlet area A out. As one can expect, for larger values of the outlet area, the final water level in a tank is lower and lower. Now you can try on your own to change other input parameters, for instance, the initial water level H0, or even try to modify the problem a little bit. How would you change your algorithm and your code if the inflow Qin is no longer constant, but becomes a function of time? And what happens to your simulation if you change the length of the time step delta t?